Hey everyone, this is Frank from targetedtechtalk.com. Today we're going to be doing a video here, which is a little bit of a technical demonstration and walkthrough for a concept that's useful in a lot of situations. So today we're going to be talking about kind of the concept of a checksum, also known as a file hash. So the um, basically just kind of define the term. What is a checksum or a file hash? It basically amounts to a digital fingerprint. So if you have a file that you want to download, for example, this is a program that I previously recommended. Sandboxy is an open source program using that you would utilize with sandboxing in Windows. You can refer back to that previous article for some details, but this is basically a free open source program that I recommend. If you want to download this file, one of the questions that we have is the file that I received, is it the same one that I requested? So basically a checksum or a file hash is sort of a unique digital identifier that corresponds to the content of the file. So if I were to alter this file in any way, um, small change, big change, anything, if I were to alter this file at all, using simple techniques or advanced techniques, its checksum would be different. So you can't modify a file without changing its checksum. So a checksum is basically a sort of algorithm or a technical process that kind of spits out um, an alphanumeric number that corresponds to the content of that file, such that if you change anything about it, whether intentional or unintentional, it produces a different number. So a checksum allows us to validate that the file we requested, for example, is the file we received. The concept of checksums is also useful in other contexts, such as digital forensics. Also utilizes this, so evidence that gets presented in court around computer crimes, um, the digital forensic technician would apply this process of utilizing checksums in their records as they're kind of doing their analysis. So it is a sort of established and proven process. In the context we're looking at it here, we can use this to verify that the file we requested is the file that we ended up with on our hard drive. So if I, for example, would request this program to download, um, I can save that onto my hard drive, and then I can compare the number that it's generated with the number provided on the website here under the checksum file. So that's what we'll be taking a look at in one moment. Okay, so now I've got two windows open here. Um, the bottom window here is a command prompt. So the exact syntax here is going to vary a little bit depending on your operating system. So I'm going to walk through the different examples here towards the end, but the overall process is the same. So we started from the website we were interested in. We downloaded the file, and so now we have that file locally. And we also took a look at the checksums that were provided on the software's website. So basically, this gives us the details. So this was the program I was interested in downloading. So this long string of letters and numbers, this is the checksum for this file. So in my local environments, my PC, after I have downloaded that file, I can run a command line utility. In Windows, it is called certutil, and you set it up with the parameters as shown here. So certutil dash hash file, then the name of the file that you'd like to verify, and then you end it with SHA-256. So that's the most common algorithm for this kind of checksums or file hash. There is other algorithms or other types, so be aware of that. But if you see SHA in the on the download page, like we did in the previous screen, that's what it's referring to. SHA-256 is the algorithm. So if I run this utility, it's going to kind of kick out a string of numbers, and if my numbers on my file matches the numbers provided on the vendor's website here, then that basically verifies that the file I requested is exactly the file that I received. So let's go ahead and do that. And there we go. So this is the number we're looking at, and just kind of comparing things, that looks to be the same as that number right there. At a glance, if you're just kind of looking through, if you kind of compare the first, few digits and the last few digits, that gives you a pretty good indication. If you saw anything off with the last few digits, that would indicate it's not the same file. So technically, the whole thing needs to match for it to be the same checksum, but you can kind of look through at a glance and see that those two numbers match. That indicates that the file that I requested is exactly the file that I received, down to the bit and down to the detail. So there was no errors in transmission, or there was no kind of funny business introduced between when I requested the file and when I received it. So that is a checksum. So to wrap this discussion up, the overall process is the same if you have a different operating system. So if you're using Linux, basically you repeat the same thing. You get the checksum from the software website, you download it, and then you open a command file or a command prompt and run the utility and compare the numbers you get to what was provided. So the only thing that's a little bit different between environments, different operating systems, is the exact command that you use. So on Linux, it's SHA-256 sum, and then the name of the file. So if you downloaded it to your user downloads, you would follow this syntax. And for a Mac, a little bit different, but a similar concept. So it's SHA sum and then -A 256 to specify SHA-256, and then if it was the user's download folder and then the name of the program there, that would generate that same number. And if that alphanumeric string, letters and numbers, if what comes back from the utility is what matches the website, then that is basically verifying that the file you requested is the file you received, kind of down to the detail. There's no way to modify the file without changing the hash. So if there was an error in transmission, the hash would be off. If it was somehow intercepted or modified, the hash would be off. So it is a good way to verify the integrity of a file. It's also sort of a concept of a digital fingerprint of that file to make sure that everything is the same. Nothing's been altered either by accident or on purpose. So that concludes sort of the lab and demo here. So if you'd like to see additional videos, go ahead and click the like and subscribe, and we'll talk to you later.